So I want us to talk through the reason that the regular hexagon construction works. So first of all, some things to think about. It is a regular hexagon, meaning that all of its sides are congruent and all of its angles are congruent. So let's talk about how we know that's true. A regular hexagon would be created by, or would include inside of it, 6 equilateral triangles. So I'm going to draw that in. So I'm just going to draw across and create these diameters. Okay, so now you can see that within the hexagon there are 6 triangles. These triangles are all equilateral. Since they're equilateral, that would mean that all of these angles, right, are congruent. They would all be 60 degrees, making this entire angle congruent to this entire angle. So recall that when I go all the way around a circle, the number of degrees I've traveled is 360 degrees. This is split up into 6 equal pieces. I know they're equal because I used the same distance to create all of these little arcs. So that means that I moved the same number of degrees as well. Since the arc lengths are equal, then at the center, those central angles are equal. 360 degrees divided by 6 gives me 60. Let's use green. So each of these angles measures 60 degrees. So that's a good start because we know that we need all of the angles to measure 60 degrees in an equilateral triangle. We also know that each radius would be congruent. So this is a radius, this is a radius, they would be congruent. So each of these are congruent to each other. They're all radii, they're connecting a point on the circle to the center point of the circle. So now, when I'm comparing these, I can see that I have side, angle, side congruence, side, angle, side, which means that all of these triangles are congruent to each other. Okay, so they're all congruent, they all have this 60-degree angle. And then when I go down here, I know that, again, since I'm using my circle, I created these arcs. I know that these would be congruent to each other as well, because the distance between the arcs is congruent, which means that this distance is congruent as well. Okay, so at the very least, I have isosceles triangles, right? Each of these would be isosceles because 2 of its sides are congruent, which means that these base angles would be congruent as well. So if I think through how to figure out that measurement, right? I know this non-base angle measure is 60 degrees, which means the other 2 have to add up to 120, and they're congruent to each other. So again, we have 60-degree angles here, which means all of these angles along here are all 60 degrees. And if that's true, then it means this entire angle, so this angle, the angle of the hexagon, is 120 degrees. This angle here is also 120 degrees. So all of the angles are congruent. So this is a regular hexagon because all of its sides are congruent and all of its interior angles are congruent.